Multi-agent designs get messy fast. Someone says, add a billing agent, a security agent, a technical agent, a verifier, and maybe a manager agent. Then nobody can answer the basic question. Who owns the next step? That is the failure this lesson fixes. Before you pick LangGraph, a tool wrapper, a queue, or a protocol, name the coordination pattern. We will use 4 patterns: coordinator router, parallel specialists, producer-verifier, and human escalation. The code is deterministic on purpose, so we can see the shape without arguing about model behavior. Start with the contracts. A task has a customer ID, a request, and a priority. An agent reply has the agent name, route, answer, confidence, and facts. A handoff records who sent work, who received it, why, and what payload crossed the boundary. The handoff object matters most. Without it, multi-agent systems turn into invisible delegation. You see a final answer, but not why billing was selected, why security was skipped, or why a human review happened. The workflow result keeps the final route, answer, confidence, replies, handoffs, and verification status together. That gives tests and traces one stable shape to inspect. Each specialist has a narrow route. Billing is not also security. Security is not also technical support. The lesson uses keyword matching because it is easy to test, but the design point is bigger. A specialist should return evidence, not just an answer. Watch the handle method. It finds matching keywords, converts those into facts, and computes a confidence value. That confidence is not magic. It is just a signal the coordinator can use. The trap is vague scope. If every specialist says it handles customer issues, the coordinator has no useful distinction. Narrow scope is what makes delegation understandable. The coordinator router pattern is the simplest multi-agent shape. One coordinator receives the task, chooses one specialist, and keeps responsibility for the workflow. In the code, a refund or charge request goes to the billing agent. The coordinator creates a handoff that says sender, coordinator, receiver, billing agent. Reason: request matched billing scope. That reason is not decorative. It is what you debug later when a customer asks why their login issue went to billing. Use this pattern when a request naturally belongs to one domain and you want specialization without a freeform agent conversation. Escalation should not be an apology pasted onto the final response. It is a workflow path. Look at the router method. After the specialist replies, the coordinator checks confidence and priority. If confidence is low or the task is critical, the system creates a second handoff to human review. It preserves the route and the confidence value. That matters because a human reviewer should not restart from zero. They should see the original task, the selected route, the uncertainty signal, and the reason the machine stopped. Parallel specialists are different from sequential delegation. The coordinator sends the same task to every relevant specialist, then merges the replies. This only helps when the branches can make progress independently. If billing has to wait for security and security has to wait for technical support, you do not have useful parallelism. You have a slower chain with more handoffs. In this lesson, a request like login error after payment timeout matches billing, security, and technical support. The merge step produces a synthesis route, averages confidence, and joins the answers. That merge logic is product policy. A different system might choose the safest answer, preserve conflicts, or escalate when any branch reports high risk. Producer-Verifier is the pattern people often describe as have another agent check it. The useful version is stricter than that. The verifier needs the original task, the producer's answer, and evidence from the producer. In the code, the verifier rejects replies with no facts. It also checks whether the answer is connected to the route or the customer. Simple? Yes. But it creates the right boundary. If the verifier rejects the answer, the workflow does not pretend everything is fine. It records a verification handoff, then sends the work to human review. Now run the demo. The router case sends a duplicate charge to billing. The output shows the route, confidence, answer, and coordinator to billing handoff. The parallel case is more interesting. Login, payment, and timeout language activate 3 specialists, and the final route is synthesis. That tells us the result came from a merge, not one specialist pretending to own the whole answer. Then the producer-verifier case accepts a supported billing answer. The final case escalates an unclear critical request to human review. 4 patterns. 1 consistent result shape. The tests are the engineering discipline behind the pattern names. Tests that billing requests reach the billing specialist. Tests that a mixed request fans out to all relevant specialists. Tests that critical or low confidence work escalates. Tests that a verifier can reject an unsupported answer. Notice what we are not testing first. We are not asking whether the prose sounds nice. We are testing the workflow contract, route, replies, handoffs, verification, and escalation. Once that is stable, model quality can be evaluated separately. Use the pattern that matches the work. If the request belongs to one domain, use coordinator router. If several independent branches can work at the same time, use parallel specialists. If the cost of a bad answer is high, add a producer-verifier boundary. If evidence is missing, confidence is low, or the priority is critical, escalate. The mistake is using all patterns at once because the diagram looks powerful. Every boundary adds latency, cost, trace data, and failure modes. Add a boundary when it creates a concrete control you can explain and test. Use this as the interview answer. Common multi-agent patterns are control flow shapes. Coordinator router selects one specialist. Parallel specialists fan out independent work and merge it. Producer verifier separates generation from checking. Escalation preserves context when the system should stop. The strong answer is not, I would add more agents. The strong answer is, I would name the pattern, define the handoff contract, decide who owns the final result, and test routing, merge, verification, and escalation behavior.